Hello, everybody. How are we? It is once again nighttime. I can't remember exactly when No, I streamed late last night as well. Yeah, but it's about 12:30, 12:34 to be exact in the morning right now, and we're gonna be getting into it. It's an interesting time for me right now, with this job that is ever looming. I want to really work to not have to do the job. I want to edit, really. Like, I want to, yeah, I want to make videos for like YouTube, preferably YouTubers, and let that be the money maker. I feel like that would be so much more preferable than just doing the clock in, clock out thing. Because of that, there's an opportunity that I have to work with a big YouTuber, and it's not like Mr. Beast or somebody of like that caliber, but like still big YouTuber, and I've got a video well underway. I've already spent hours working on this video, and I want to continue. I want to continue on it. It is due Wednesday of next week, and so or this coming, I guess, because it's Friday, so it's Wednesday of this coming week, and so I want to really bang that out and get that done. But anyway, all that being said, we're probably only going to do this one. Wait. Is this the right one? Spread across. Yes, this one. We might only be doing this one. I am excited for this one, though. I've heard the term API, but I didn't know what it stood for. I didn't know what it really meant. So this will be interesting. This will be interesting for me. Yeah. All right. Without further ado, had to get the yawn in. Okay. Without further ado, let's get into this.
So now that we're solving our problem using a series of cooperating applications communicating across a network, we're going to talk a little bit more detail about the notion of what we call web services. And in this, we're going to take a different perspective. Instead of building our application and breaking it into pieces, we're going to have an application that's going to really consume an API from somebody else. So there is some other provider of this API that's not us. And so
Okay. Application Program Interface, API. The API itself is largely abstract in that it specifies an interface and controls the behavior of the objects specified in that interface. The software that provides the functionality described by an API is said to be an implementation of the API. The software that provides the functionality described by an API is said to be the implementation of the API. An API is typically defined in terms of the programming language used to build an application.
If you're going to talk to somebody's data, like Google or Amazon or Twitter, they're going to say you have to use our API. So what's that? So an API is a contract that says, look, if you do this and this and this and this, we're going to give you data this way. And they set the rules. They tell you what the URLs are. They'll tell you if it's XML or JSON. And this is called the application program interface. And it's something you read and you understand. And so you go look at the documentation. This is the documentation for the Google Maps API. So it turns out that Google knows a lot about maps. It knows a lot of data. It knows how to search maps. And it actually provides some of those features to you that your application can take advantage of. I took advantage of this at one point by asking all the students in one section of one of my online courses where they were from. And I just let them type in where it was. And then I said, well, I don't know how to code any of that. So I used this API doing what's called geocoding to look all those places up and get precise latitudes and longitudes for the ones Google could figure out. And that saved me a lot of work. Now, these are expensive resources, but I could be patient and make use of these resources, which as long as you use them not too much, they can be free. We'll talk a little bit more about rate limiting and what's free and what's not in a bit. But you start by reading documentation. It says, do this, hit this URL, hit that URL. So if you read that document,
Wait, where did it say that?
it says, do this.
Hit this URL? Wait.
Hit this URL, hit that URL. Hit that URL.
Status OK, results, geometry, location type, approximate location, there's the coordinates, address components, long name, Ann Arbor. Wow, I'm so much. Locality, political, short name, Ann Arbor. That's weird. Why does it say this? Long name, short name. Formatted address, Ann Arbor. JSON.
So if you read that documentation, you will find that there is a URL that you can hit, and they tell you where to go. And then you go to this URL, you add a question mark, and then you say address equals, and then Ann Arbor plus, and there's all these rules. These are called URL encoding rules when you have key values on URLs. The plus means these rules. These are called URL encoding equals, and then Ann Arbor plus, and there's all these rules. These are called URL encoding rules when you have key values on URLs. The plus means space, and %2c means comma. So these are called
Key value?
URL encoding rules when you have key values on URLs. The plus means space, and %2c means comma. So these are called URL encoded. But don't worry too much about that because we're going to URL 2c means comma. So these are called URL encoded. But don't worry too much about that because we're going to have a magic library like we always do in Python that takes care of this. And so if you were to hit this URL, you type it in the exact right way in your browser, you will get back a JSON document. It's an object that has key value pairs. The first value is this status, then it has these results, and it's a list. And you dive down, and eventually you can kind of find the latitude and longitude of the thing that you are looking for. And so the idea is, can we write a program that can read this? And so here's our
Oh my gosh, bro.
Our little program that reads this.
Okay, let's try and break this down. Import URL lib, parse, error, import JSON. I wonder if we can just do that like soup, you know what I'm saying? Service, URL, while true, address input, enter location. If length of address is less than 1, break. URL, service URL plus. parse urllib parse URL encode address print retrieving URL. Okay, central location Ann Arbor. Is that Missouri? I think it is. Retrieving. Wait, where to get the URL? Oh, because it just as the service URL. So it used that. Okay, yeah. Equals URL lib dot request URL open. So that opens the URL. Read decode. So decodes it. Because hold on. It encodes it up here. Yeah. Decode, print, retrieved, length, data. There's that. And then characters. Cool. Try. JS equals JSON dot loads data. I don't know what loads is. Except JS equals none. If not JS or status, not in what the heck is status? If not JS or status, not in JS or JS. Status. Oh my gosh, what the heck? And that's if it is not, right? Okay. Print failure to retrieve. Print data continue. Latitude. Result 0 geometry. What the heck? Wait, retrieved. Oh, print data. No, I wouldn't have run any of those. Oh. It continues. I kind of disregard this. Latitude equals JS results 0. Geometry. Location. Latitude. And then... Why does it say lat again? LNG. Well, good heavens, I'm just yawning everywhere. LNG. Print latitude. Lat, then LAT. Longitude, LNG. Location equals JS results. 0 formatted address. Print location. So there's latitude and longitude, Ann Arbor. Then it continues again.
And a lot of this is sort of comfortable. You've already seen some of this. Yeah. You import URL lib. We have to parse them JSON. We grab the URL. And then we're going to write a little while loop that's going to ask for a location. And we can type that location in. And we've got to concatenate with this URL the location equals. And there is a bit of code, a library that called parse URL encode, that takes the key and the value. So the address equals, and then whatever this text is that we read in from the user, that goes in here. And it does that URL encoding with the pluses and the %2C and all that stuff is taken care of. and that is our URL that we're going to pass to URL open. So we print out that we're going to retrieve it, prints this out, and if you look at this, it's too long, it has all that fancy stuff on it, and then we read it. We open it with URL open, and then we read it and decode it. So these two things, hit this URL, decode it, and then we retrieved 1669 characters, because it's just in this case, because we've decoded it, data is a string now. That's read is bytes and data is a string. So we read that many characters, 1669 characters, and then we're going to take this data and we're going to parse it with JSON, and we might get
Wait, why? How?
bad data here. It might. So we read that many characters, 1669 characters, and then we're going to take this data and we're going to parse it with JSON.
Is that what loads is? I guess.
And we might get bad data here. It might blow up, but it might work. So in this case, it works. We have an error that basically says if we got a bad thing, we're going to blow up, but in this case, it doesn't blow up. And so now we're going to sort of dig through. And if you go back, let me just.
So is this the error thing, if not JS? Or status? Not in JS? Or if JS status is not okay?
Just go back. So the results, sub-zero, geometry. Let's show you how that works. So results is the first key. So this is a dictionary with a key of results, but then it has a list, and the zero item, this list starts here and goes there, and I'm only going to show part of it, but there's many things here. So the zero item is this. This is the sub-zero. And then geometry within that sub-zero item. So if we look at that, it is the outer dictionary, the first item of the list, sub-geometry. So that grabs one part, that grabs this part right here.
Oh my gosh, geometry, status okay, results.
And then
where is this? Like, I don't know where it, like, back up a little bit.
That, just go back. So the results, sub-zero, geometry. Let's show you how that works. So results is the first key. So this is a dictionary with a key of results, but then it has a list, and the zero item, this list starts here and goes there, and I'm only going to show part of it, but there's many things here. So the zero item is this. This is the sub-zero. And then geometry within that sub-zero item. So if we look at that, it is and geometry within that sub-zero item. So if we look at that, it is the outer dictionary, the first item of the list, sub-geometry. Sub-zero item. So if we look at that, it is
what?
The outer dictionary, the first item of the list, sub-geometry. So that grabs one part, that grabs this part right here. And then we're going to go into location and lat. And those are just keys within keys, a dictionary within a dictionary. And so you see it says sublocation, sublat. And so that is literally going to pull out of that complex structure, that will pull the latitude out, and then in the next line, pull the longitude out. So we can pull the latitude and longitude out, and then we print it out. We can go into results sub-zero formatted address, and that goes into results 0 formatted address, and that pulls this little bit out. Now it takes a little while to write this stuff, and you have to put a lot of debug, and you don't necessarily figure out this complex bit here at the end, but you know, you print it, you don't get what you want, you say, oh wait a sec, that was an array, so I got to add a little sub-zero there to get the first one out of the array, but eventually you figure it out. And it's not all that difficult. It's the first few times you do it, I'm like, what am I doing? But after a while you realize, oh, I'm just sort of tearing this apart and digging deeper and deeper into this data structure, which I just retrieved over the internet from Google, and I learned something good from that. So up next, we're going to talk about how
API security and rate limiting. The compute resources to run these APIs are not free. The data provided by these APIs are usually valuable. The data providers might limit the number of requests per day, demand an API key, or even charge for usage. They might change the rules as things progress.
sometimes these APIs protect themselves with keys or signatures, and why that happens and how to solve those problems.
Cool. It was application program interface. Boom, 73%. All right, we're moving on up. Oh, look at all these. What? Oh my word. Might be sitting here a little while. But that is going to do it for today, everybody. We learned a bit about APIs, which is good. Thank you guys so much for watching. If you enjoyed this video, please like and subscribe, and please leave a comment down below if you have a prayer request. I'd love to know how I can be praying for you guys. But for right now, love God, love people, and I'll see you guys soon. I mean, you should love God and love people more than just for right now, but I will see you guys soon.